Welcome to Module 6, KINS Chapter 10, Part 2 lecture. This is the second part of the lecture from last week where we started looking at our dosage calculations. So this week's lecture will be short, but there is a lot of information within. So we're looking at converting metric order to household measurements. So let's look at an example here. There's an order for 30 milliliters of an oral antibiotic. So what household unit of measurement did we talk about in the previous slide that talked about it's an equal measurement to? So we talked about 1 tablespoon equals 15 milliliters. So in order to do this, you must divide the order by the conversion factor. So 30 milliliters divided by 15 milliliters. And you get 2, but the important part here is that we don't get 2 milliliters anymore. And this is where huge mistakes could be made. So it's important to understand that we're now converting from that metric to the household measure. So when we're doing any kind of mathematical equations, it's important to label. So we are now going to 2 tablespoons. You can also set this up as an equation with the order amount on the left side of the equation and the conversion factor on the right side. So if you're looking at 30 milliliters times 1 tablespoon divided by 15 milliliters, because 1 tablespoon is 15 milliliters, then you can cross multiply and the milliliter unit cancels out. So you have 30 times 1 divided by 15, which equals 30 divided by 15. And again, it's the same thing. We're not talking about milliliters anymore. We're talking about tablespoons. It's important to start with the basics and really build a foundation. So if you're just starting out, you need to make sure that you understand all the steps before you kind of go into simplifying or shortening things. So let's look at another example, and this is coming from your book. The way they're setting it up is drug have times drug wanted divided by have equals the units wanted in the new system. So the drug have is the unit of measurement that is on the label. So that's what we also call the drug on hand. Wanted is the amount or strength ordered by the physician, or what we also call doctor ordered. And then the have is the conversion, because he ordered, if you look down here on the physician order, he wanted 30 grains of Lasix. So if we're looking at that, we need a conversion. So we need to know here if he wanted grains, but we only have 1 gram tabs, what do we need to do? So we need to know here that 15 grains equals 1 gram. So the example here is the physician order is to administer 30 grains of Lasix. And on the label, we have 1 gram tablets. So again, you must know the conversion that 15 grains equals a gram. And then you must convert the order to the unit of measurement, so grains, to match the unit of measurement on the drug label, which is grams. So 1 gram is what's on the label, multiplying it by 30 grains, because that's the physician order, okay? And then we need to divide that by 15 grains, because this is the conversion factor, which equals 2 grams, or it's equal to 2 tabs. And we'll look at this more closely in class, because we also are going to use doctor ordered over doctor on hand equals X for our pill format, and then doctor ordered over doctor on hand times the quantity equals X for our liquid format. So there's a lot of different ways that you can set up these problems, and it's good to look at them and see which one makes more sense to you. But bottom line is, we're taking what the doctor has ordered, we're looking at what we have on hand, we're making any conversions that we need to make, and then we're calculating the amount so that it's an equal amount what we have on hand equals exactly what the doctor ordered. So calculating drug dosages for administration, the formulas use the strength and dose units. For liquid, it's a solute, so it's called a solvent when it's dissolved. And there's available in the ordered strength. So it's the same kind of thing because we have it on hand, and then we have what was the order, okay? So the standard formula here, available strength divided by the ordered strength equals the available amount divided by the amount given. Again, we can also look at this as doctor ordered over doctor on hand times the quantity will equal X. Both of these be the same. So available strength means the strength of the medication that we have on the label, and the ordered strength is the amount that the physician ordered. So here's what I was talking about. For an alternative formula, which we will use in class, doctor ordered over doctor on hand times the quantity will solve for X. So regardless of which formula is used, the answer will still be the same. So D is desired dose, or the physician's order, or doctor ordered. H is what's on hand, which is the dosage strength listed on the medication label. And quantity in the unit, so it's identified on the label as 1 tablet, for example, or 5 mLs, etc. So we take doctor order over doctor on hand times quantity. An alternative formula for this, either way, again, you're going to get the same results. We typically, when we practice in class, will utilize this formula. You want to complete the various problems for preparing an injectable dose. You want to also be able to determine an oral dose and other sample problems in the textbook, which we have in the textbook as well as in your study guide workbook. That's why it's so important to be practicing. I've also provided you with an entire math packet that builds you up to these dosage calculations, and then also shows you in different ways how to solve for the dosage calculations. You can see procedure 10-2, which describes how to convert among measurement systems. So you want to take a look at that and make sure that you understand that as well. So pediatric doses. Pediatric doses are different from those in other age groups. There's really important factors, and that is that they need to be more accurate because we're talking about a child or even a baby, an infant. And so there are some different factors that are taken into account when calculating pediatric doses. And the one way is by body surface area or weight. And you must be especially careful in calculating dosages for children because even the smallest of a mistake could be dangerous or even fatal. So we want to look at how do we look at doing it by a child's weight, because this is what the most common thing as a medical assistant, if you're doing calculations, that you're going to be responsible for knowing and understanding and checking. So if it's based on body weight, it relies on the child's accurate weight, which we've discussed this so many times as far as why are those vitals so important when you're rooming a patient, especially with children. And that is because you need to have that accurate weight in order to be able to calculate the dose. And again, we just said that if you're off even by just a little bit, which means even if you're off in weighing the child by just a little bit, it can be very dangerous and sometimes fatal. We typically take the child's weight in kilograms. So it's important that you understand how to convert for your dosage, for your weight, when you're looking at pounds to kilograms. And basically, when you do this, you want to convert the child's weight to kilograms by dividing the number of pounds by 2.2. So 1 kilogram equals 2.2 pounds. So the way I like to look at this, and I've told you this in class, is I like my weight better in kilograms because kilograms is a smaller number. So when you're looking going, okay, wait, is that pounds or kilograms? If you remember that you want to get a smaller number, that means you divide by the 2.2. So you carefully weigh the child to make sure you have an accurate weight, and then you do the step we just talked about, which is to convert to kilograms. After you have the weight converted to kilograms, you want to calculate the total daily dose of the medication by multiplying the child's weight in kilograms by the amount of drug stated on the label that should be administered, and that's kilograms per day. Then we calculate a single dose of the drug based on how frequently the medication is to be given throughout the day. So for example, if we're giving it 2 times a day versus 3 times a day, you're going to have more medication calculated out, right? Because they're only getting that total amount 2 times a day. So we're dividing that out by 2. Then, after calculating the amount of a single dose, you want to compare the ordered amount with the drug label and apply the standard formula to calculate for the amount of medication that should be administered. Again, we're using our critical thinking. We're always looking at each step and asking, okay, does this part make sense? You're checking your calculations, and then you're kind of working backwards once you get your calculations to say, okay, this is what the doctor ordered. This is what I'm about to administer. Does it add up? And you can look at procedure 10.3 here. So reconstituting powder injectable medications. It's very important in these cases to read the label and the insert information and to understand it, because you need to know exactly how much sterile solvent must be added to the solute to create the ordered dose strength. So again, you can see the example in the textbook, and you want to make sure that you understand that you need to read the information, the label and or the insert packet, to make sure that you have added the correct amount of sterile solvent to this medication. It comes in crystal or powder, and it's mixed with isotonic saline or sterilized water. That's the part that you're typically measuring out and then putting into the vial to mix. And this forms a solution. And sometimes it has to be made before an injection. Not a lot of them need to be mixed. I'm trying to think. I think our trying to think which one in peds was. It wasn't our MMR. It might have been. I'd have to look that up because it's been a while. But only 1 out of the 7 regular normal injections that we gave regularly on a daily basis did we have to actually reconstitute the powdered injectable medication. So again, I'm going to say this: read the label directions carefully and make sure that you know the exact amount of the sterile solvent or the sterilized water that needs to be added in order to reconstitute. So what are the legal and ethical issues here? So we must master dosage calculations. Again, we've talked about, we even shared and worked through a situation where there was a 3% saline or sodium chloride that was ordered for a child because they were having the loss of salt in the body, and then they got better. So it was the normal saline, which is the 0.9%. And somehow we ended up with a 10% solution, which wouldn't make sense. And we should understand that that doesn't make sense because the mistakes can be fatal. So you're also responsible for your own actions. And that means if you take a shortcut or you don't check yourself or you're in a hurry and you miscalculate and you didn't do a double check, so many times you want to take the shortest way. This is not the time to take the shortest way.